So there is something called in coordination complex primary and secondary valency. Primary and secondary valency. Primary valency is nothing but it is connected to the oxidation number. Oxidation number, and secondary valency is the coordination number. Right, that's it. Very simple one. For example, if I am taking cuprammonium sulfate complex, Cu ammonia 4 times SO4, this complex if I am taking, what is the oxidation number of the copper here? +2. Right, oxidation number of the copper is +2. So that is, this is the primary valency. This is the primary valency, whereas coordination number is 4 here. This is secondary valency. Okay, so just to give an idea regarding primary and secondary valency, I had taken care of this. This is being again proposed by this. Under the Warner's theory only it comes into the picture. Okay, so one more important aspect will switch over to students. Let us try to name the coordination complex. Quickly we'll rush through. Naming part, that is IUPAC name. So this is the one of the area the question could be asked. You know, the one question may be anticipated from the IUPAC naming part. Naming part, one question could be expected from the IUPAC nomenclature of the coordination components. Let us take few examples and rules also we will be having. We will go through once again. So we have, I have already said, students, there are 3 types of complexes we will be having. One is we have a cationic complex where the complex ion will be having a positive charge, and we have anionic complex where the complex ion will be having negative charge, and we will have a neutral complex. We have a neutral complex, right? So neutral complex will be named by one word, directly one word will be used and named, and this will be having a splitting one. So always remember, the first rule you have is, first rule for you is IUPAC nomenclature. It could be the cationic, anionic or the neutral complex. You always start from the left and go towards the right. So you always go from left to right while naming the coordination complex. You always go from left to right. This is the one of the clue you are having. For example, if I am having cobalt, hexamino cobalt complex, if I am having cobalt, that is sulfate, right? This is the complex if I am taking. What has to be done is you always go from left to right. So when you go from left to right in this particular thing, which one you will encounter first? You have 2 parts to the coordination complex. Any coordination complex you have 2 parts, right? That is, you have a complex ion you are having, another one is you have a complex ion you are having, another one is you are having a counter ion, right? Am I right? One is you are having counter ion, one more is you are having a complex ion, right? So you start with always from left to right. This is a cationic complex. Which one is at the left side? First you will encounter, when you go from left to right, first you will encounter the complex ion, then afterwards you will encounter the counter ion. So first you name the complex ion, then you go for the counter ion. If it is, for example, K4 FeCN6, if I am taking this complex, right? K4 FeCN6 complex if I am taking, what needs to be done? You go from the left to right, student. So which one you will encounter in the case of the anionic complex? Left side. So first you will encounter the counter ion. So you name the counter ion first here. Afterwards you go for naming the complex ion. Naming the complex ion. Very clear? So even if you consider the nickel tetracarbonyl, for example, that is a neutral complex we had gone through, you start from left to right. That is only one system is there, that is you have a naming only for this. You don't have to consider the counter ion, no counter ion is there. So I mean, so first rule for you is, whenever you are naming a coordination complex, keep it in mind, you go from left to right. If you encounter the cationic complex, you will encounter the complex ion. You name complex ion first, then you name the counter ion. In the case of the anionic complex, you will be getting a counter ion first. So name the counter ion first, then we will go for the naming the complex ion. Such kinds of problems will not appear in this case, right? So in the complex ion, the next rule for you is, I'll go for the next rule. In the complex ion, if you consider complex ion whenever you are naming, again complex ion when you are naming, you have to come from right to left. That is, complex ion when you are naming, you need to come from right to left. I am going for this. See, this is, I am talking about the coordination compound as a whole, coordination compound or complex as a whole. Coordination complex consists of counter ion, complex ion, right, complex ion plus counter ion. Don't confuse. Coordination complex consists of counter ion as well as complex ion. You start from left to right. In the complex ion naming, you always start from right to left. That means ligand you name first. That is, right side you have a ligand. You take the complex ion, any complex ion for that matter, you have a ligand at the right side written, and the left side you will be writing the metal ion. First name the ligand, then come for the metal ion. We do respect the ligand here because ligand is the donor. It has given the electron. Ion or the any metal ion for that matter, it has accepted. It is a taker, right? So donor will be respected. That means donor will be named first. Then will be coming for the acceptor, right? Or in other words, first you go for the left to right, then you take right left. Got it? Right to left. That is the second rule for you. So that means naming, how to approach the naming, you have done it. How to approach the naming part, you have done it. The next part what has to be taken care is, third point for you is, for example, see, in the case of the ligand naming of the ligand, see, whenever you see the ligand which is ending by, for example, IDE. If it is ligand is ending by the word IDE, for example, we say Cl minus, how do you name? We will be naming as chloride, students, right? We will be naming as chloride, right? So if you are having, Br minus, how do you name? Bromide, right? So I am talking about naming the ligand specifically, then we will come for the naming the complex as a whole. So if you are having, if the ligand ends by the word ID, then you always replace IDE by O. Clear? IDE has to be replaced by O in the while naming the complex. Whereas ITE or AT, if you are having, replace E by O. That's it. You don't do anything. You replace E by O. Replace E by O. That's it for you. Very simple. Right? So first rule is left to right. Second rule is right to left. Third rule you have is, I am talking about now the ligand, naming the ligand. So what has to be done? If it is a chloride ligand, it will be named as chloro. Right? If it is bromide ligand, it is named as bromo, right? IDE has to be replaced by O, right? Bromo, hydroxide ligand, this is hydroxide ligand, right? Hydroxide you have, right? How do you name? Hydroxo, right? Hydroxo, right? Hydroxo. O2 minus, what is this? Oxide ligand, right? Oxide. How do you name? Oxo. IDE has to be replaced by O, that is oxo. Very simple. IDE has to be replaced by O, that's it. If it is word ending with IT, ligand having the word ending by IT, then what you have to do is, you have to replace E, last E has to be replaced by O. If it is ATE, same thing, ITE or ATE, last E has to be replaced by O. Or in other words, for example, you are having nitrate. What will be name? Nitrato, right? Nitrate ligand, NO3 minus, right? If you are having, for instance, nitrite, NO2 minus, nitrite if you are having, how do you name? Nitrito, right? That is, just replace E by O, don't do anything. right? For example, if you are having acetate ligand, CH3COO minus, how do you name? Acetato, right? Acetato. Oxalate ion if you are having, oxalate, right? How do you name? Oxalato, right? Oxalato. Sulfate ligand if you are having, ligand ending by sulfate, how do you name? Sulfato, right? And so on and so forth. Very simple for you, right? Very, very simple approach. What has to be done? If the ligand ends by the ITE or ATE, replace E by O, that's it. If it is IDE, replace entire IDE by O, that's it for you. And last clue is, as an entire thing, what needs to be done is the entire aspect, that is anionic complex. Anionic complex, always anionic complex, I am talking about the metal ion end by ATE, anionic complex, metal ion end by ATE. If it is anionic complex, end the suffix has to be kept ATE. In the case of the cationic complex, you don't do anything. For example, if I am having, the complex containing iron, what will be done? You have to write iron. If it is positive cationic complex, you keep it as iron itself. If it is anionic complex, instead of writing iron, you have to write it as ferrate. Right? You have to write it as ferrate. If it is a complex containing nickel, you write it as nickel as such if it is a cationic complex. If it is anionic complex, you have to write it as nickelate, cobaltate, manganate. Got it, right? That is cuprate, zincate, and so on and so forth. Very simple. If it is an anionic complex, if it is cationic complex, keep it as such, and always remember, I am talking about the, I have done with the, the ligand naming. I am talking about the metal ion end by the word ATE in the case of the anionic complex, and also always keep oxidation state of, always keep oxidation state of metal in bracket. That's it. In bracket, what has to be done is, in parenthesis, you have to keep it, the oxidation state of the metal in front of the metal. If it is iron 3, iron 2, all those things has to be kept. Nothing else need to be done. Very simple. And one more important thing here is, as far as the metal ligand is considered, I forgotten, student, if it is a bidentate, tridentate ligand, it's already having di, tri, etc. You have to introduce bis, tris, tetrakis, right, etc. has to be introduced instead of putting di, tri, etc. because a ligand is already having di and tri. Ethylene diamine, already di is there. In that case, what has to be done is you have to keep bis, tris, tetrakis, etc. Got it, right? So that's it about the IUPAC nomenclature. Very easy. It's very easy. We'll take some of the examples, students, and we'll try to name by using the IUPAC nomenclature.